What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 4, Practice Test. Let's do it. Determine whether the following algebraic equation can be written as a linear function. Well, this is indeed a linear equation because we have no exponents. And we want to represent it as a linear function. What that really means is we're saying y as a function of x, aka isolate y. So first, I'm going to subtract 2x from both sides. So we got negative 2x plus 7. Then we're going to divide by 3. We got y equals negative 2 divided by 3, or negative 2/3 x, plus 7 divided by 3, or 7/3. So that's how you would do it. So the answer is yes, boom, done. Determine whether the following function is increasing or decreasing. Now, we know that this is a linear function, okay? A linear function either goes like this or like this. And increasing means a positive slope. A decreasing function means a negative slope. By the way, it could also be a flat line with a slope of 0 or a vertical line with an undefined slope. But we're just in these two categories, increasing or decreasing. So the question is this linear function, does this linear function have a positive or negative slope? The slope is next to the x. So it has a slope of 7, which is positive, which means this is increasing, boom, done. Find a linear equation that has an x-intercept at -4, 0, and a y-intercept at 0, -6. So the only piece that's missing, since we have the y-intercept, is our slope. And when we have two coordinates like this, we can calculate the slope by subtracting down, right? We take the difference of the y values on top, 0 minus -6, which just becomes a plus because of the double negative, over subtract the x values in that same order, -4 minus 0. So this gives us a slope of 6 over -4, which is a slope of -3 over 2. Now, since we have the y-intercept, I can put this immediately into slope-intercept form, which would be y equals my slope of -3 over 2x plus my y-intercept, which is -6 or -6. There would be the linear equation. Boom, done. To write an equation for this line here, we want two things, right? I want to know what's the y-intercept and what's the slope. And I can see that the y-intercept is right here at -1. Now, what about the slope? Well, if I get two nice, easily identifiable points like this, I see that I'm going down 2 to the right by 1. That's down 2 on top, rise, that's -2, +1 going to the 1 to the right on the bottom. So it's a slope of -2, okay? So then my equation in slope-intercept form is y equals my slope, -2, times x, plus my y-intercept, plus -1, aka -1. There's the equation, boom, done. Does table 2 represent a linear function? If so, find a linear equation. So we're going to first look at all the changes in x, which this goes up by 2, goes up by 4, and goes up by 4. And then we're going to look at all the corresponding changes in y values. So this goes up by 5, this goes up by 10, this goes down, by 7. And then we're going to look at the ratios of each of these changes in the function value over the changes in the x value. And if this is a linear function, they should all be equal to each other. So I have 5 over 2, then I have 10 over 4, which does equal 5 over 2. So far we're looking good. And then I've got -7 over 4. Obviously, this doesn't equal 5 over 2 because it's negative first and foremost, but obviously the numbers are different. This means this does not represent a linear function, so we can't create a linear equation. Boom, done. So here we're determining if these lines are parallel, perpendicular, or neither. So I like this top equation because I've got it in slope-intercept form, because to make this determination, we really have to look at the slope, that value multiplying the x when we're in slope-intercept form. So to get this one into slope-intercept form, I'm going to isolate that y. So first, I'm going to add 4x to both sides. Then I'm going to divide by -3, which gives me -4/3 x plus 8 divided by 3. Okay, so this one has a slope of -4/3. Okay, so then we look at the two slopes, 3/4, and that is the opposite reciprocal of the other one. When you have a slope that is opposite reciprocal of another slope, those two lines are therefore perpendicular, and that's the final answer. Boom, done. To find the x and y intercepts, we have to remember that the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. And then we just plug and chug, right? If I plug in 0 for y, that goes away. I get 2x equals -14. Divide by 2, and I get x equals -7, okay? And then likewise, when I plug 0 in for x to get the y-intercept, that basically goes away. 7y equals -14. Divide by 7, y equals -2. So there are my x-intercept and y-intercept. -7, 0, x-intercept, 0, -2, y-intercept, boom, done. Write an equation for a line perpendicular to this passing through 8, 10. So perpendicular means the slope is opposite reciprocal, meaning that's positive, so it's going to be negative. That's 4 over 1, so it's going to be negative 1 over 4. And then we're going to use point slope to factor in this coordinate. So I say y minus that y value of 10 equals my slope, negative 1/4, times x minus the corresponding x value of that coordinate. Then we're going to distribute because we're going to put it in slope-intercept form. That's negative 1/4 x. Negative 1/4 times negative 8 is positive 2. Last but not least, we're going to add 10 to both sides. And we get y equals negative 1/4 x. Could also be written as negative 0.25 x plus 12 for the win. Boom, done. So in order to graph this linear function, we see that we have a y-intercept and a slope because it's in slope-intercept form. The y-intercept is 6. What about that slope? Remember, if there's no number in front of the x, it's 1. But here it's a negative. So really, it's a slope of negative 1, which we could also write as negative 1 over 1. So what does that mean? The rise is negative 1, so we go down 1. The run is positive 1, so we go to the right 1, like so. So boom, boom. Then we're going to connect the dots, and there's our final answer. Boom, done. For 19, we've got two plans. We've got plan A and plan B, and we're trying to figure out when B is going to save you money. So really we need to first figure out when they're equal. And then since B, you basically save money as you go further because there's no cents per mile, right? So after you pass a certain threshold, B is going to be cheaper. We just got to figure out when that point exists. So plan A would be 25 per day plus 0.1 or 10 cents, $0.1 per mile. So X is the number of miles. We're trying to figure out when that's going to equal 40 with free unlimited mileage. So it's just a baseline rate of $40 per day. So then we're going to isolate X. Now that we have this nice equation, we get 0.1X equals 15 divided by 0.1, and we get 150. So that's when they're equal. So for B to be better, we need to drive more than 150 miles. Boom, done. A town's population increases at a constant rate. In 2010, the population was 65,000. In 2012, it was 90,000. Assuming this trend continues, predicted in 2018. So we're going to make a linear equation, and we're going to do so by these 2 points. So 2010, I'm going to count that as year 0, just going to make things easier. And that has a y value or population value of 65,000. And then the x value will be the years since 2010. So 2012 would be 2. And there the corresponding y value is 90,000. And then we're going to use this to calculate our slope. So we take the difference of the y values on top by subtracting down, as we always do here, over the difference of the x values, 0 minus 2. So 65,000 minus 90,000 is negative 25,000 over negative 2, which gives us a nice slope of 12,500. And then this is our y-intercept, which means the equation for this line is y equals 12,500x plus 65,000. Now if we're trying to figure out 2018, again, that's 8 years from 2010, meaning we plug 8 in for x here. So 8 times 12,500 is actually exactly 100,000. And then 100,000 plus 65,000 gives us 165,000 as a prediction. So it would be a population of 165,000. Boom, done. Okay, so for this question, we're meant to make a linear function based on this graph. And the thing is normally for linear functions like this, it's easily, you have points that are easily identifiable. For some reason for this problem, they're not very identifiable. But what I'm going to do here is I'm going to show you how you should be able to do it and kind of reverse engineering these coordinates. So I'm going to give you the coordinates, and then I'm going to show you what the process for figuring out this linear equation. So let's assume that we do have these nice, easily identifiable coordinates. Then what you're going to do is you're going to calculate the slope, right, by stacking the coordinates, subtracting down. So let's do that. So first we have 28,125 minus 19,375 on top over the difference of the x values, which is 20 minus 10, subtracting top minus bottom. So this gives us 8,750 over 10. So that gives us a nice slope of 875. Now using point slope, I'm going to use the first coordinate 10, 19,375. So we'd have, let's see if we have room for this, y minus 19,375 equals slope times x minus that corresponding x value of 10. Now we're going to distribute. Let's do it up here. And then I have y minus 19,375 equals, down here, we got 875x. And then 875 times negative 10 is negative 8750. Last but not least, we're going to add 19,375 to both sides. And then we get, let's see if we got room here, y equals 875x plus, and then 19,375 minus 8750 is 10,625. So there is your linear equation. Boom, done. In 2004, school population was 1250, and then by 2012, it had dropped to 875, assumed the population is changing linearly. So from 2004 to 2012, it's dropped by 375. We get that by 1250 minus 875, so that's that. What is the average population decline per year? So we take this total change, and that happened over a period of 8 years. So it's 375 divided by 8, and that simplifies to 46.875 people per year is how the population is declining. And then last but not least, find an equation for the population t years after 2004. We got everything beautifully set up, because if we're saying t years after 2004 is times 0. So this is our y-intercept right here. So we have y equals our slope of 46.875. But again, since it's going down by this amount, that's negative times t, and then plus that y-intercept of 1250. There's our equation. Boom, done. So for this one, we draw a line of best fit. We're just trying to kind of get a line that goes to the best of our ability through the middle of all of these guys. So, something like this would be a nice line of best fit. You see there's a nice distribution of points kind of like above and below that line. So there's a nice approximation for the best fit line. Boom, done. So this question asks, in what year will the percentage drop below 4% for the percent graduates? So I think we're trying to kind of assume that this is a linear, changing at a linear rate. The problem is like the slopes actually don't all equal each other. So what we're going to do is we're going to run this through a linear regression model and then use that equation to make this prediction. So there's our data plugged in, and using the linear regression calculator, we've got a slope, we got a y-intercept. So let's write that out in the linear equation. So it would be y equals negative 0.219x plus that y-intercept of 8.410. And then we want to know, when will the percentage drop below 4%? Again, y is my percent, so I'm going to plug 4 in for y. Now we're going to solve by subtracting 8.41 from both sides. That's negative 4.41 equals negative 0.219x. Last but not least, we're going to divide by negative 0.219, like so. Last but not least, we're going to divide by negative 0.219 on both sides, like so. And we get approximately 20.1, which means this is a little bit more than 20 years from 2000. So that means it will drop below 4% roughly in 2020. Boom, done. For 31, we're going to use a linear regression to determine a function y where the year depends on the population, right? You can see that this is the year here for the y values, 2003, 2006, etc. And then this is the population, which is the x value. So now that we have these points in the linear regression model, we get these values, which will help us come up with the equation of the line. So we have y equals 0.00455x plus that y-intercept of 1979.5. Boom. So this question asks, what is the correlation coefficient for this model, which we can calculate from the linear regression model? So let's plug these points in as follows. And now we have the correlation coefficient, which is that R value right here, which if we round it to the nearest thousandth would be 0.999. Boom, done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.